THHN wire offers several advantages over UF wire, even in wet or damp locations. Firstly, THHN wire generally exhibits greater flexibility compared to UF wire. This enhanced flexibility simplifies installation, particularly in confined spaces or when navigating sharp bends. The increased pliability of THHN wire reduces the risk of damage during installation and allows for easier routing through complex pathways within walls or conduits. Secondly, THHN wire is often more cost-effective than UF wire. This price difference can lead to substantial savings, especially in extensive electrical projects requiring significant amounts of wiring. The low material cost of THHN wire makes it an attractive option for budget-conscious installations without compromising performance when properly installed within the correct raceway. Thirdly, THHN wire is available in a broader spectrum of sizes and colors than UF wire. This extensive selection enables precise matching of wire gauge to specific circuit requirements, optimizing current carrying capacity and minimizing voltage drop. The variety of colors also simplifies circuit identification and troubleshooting, which helps the electrician. While THHN wire offers these benefits, it's crucial to acknowledge its limitations. THHN wire is not as inherently resistant to moisture and abrasion as UF wire. This means THHN wire typically requires installation within a suitable conduit or raceway to provide adequate protection against environmental factors. The selection of appropriate conduit, such as PVC or rigid metal conduit, depends on the specific application and environmental conditions. Firstly, consider the location of the wiring. For direct burial applications, UF wire is generally preferred due to its superior moisture resistance. However, THHN wire can be used in underground applications if installed within a waterproof conduit. Secondly, assess the potential for physical damage. In areas where the wiring is susceptible to abrasion or impact, a robust conduit like rigid metal conduit provides enhanced protection. Thirdly, evaluate the environmental conditions. In corrosive environments, select a conduit material that is resistant to chemical degradation. For example, PVC conduit is suitable for many corrosive environments, while stainless steel conduit offers superior protection in highly corrosive settings. The National Electrical Code (NEC) provides comprehensive guidelines for selecting and installing wiring and conduit systems. It's essential to consult the NEC to ensure compliance with all applicable regulations and safety standards. NEC Section 310.10 provides requirements for uses permitted. This section outlines the acceptable applications for various types of conductors, including THHN and UF wire. NEC Section 300.3 addresses the requirements for conductors of different systems. This section specifies the conditions under which different wiring systems can be installed in the same raceway or enclosure. NEC Chapter 9 contains tables and examples for calculating conduit fill. These tables provide guidance on determining the maximum number of conductors that can be installed in a specific size of conduit. When selecting THHN wire for a project, consider the ampacity requirements of the circuit. The ampacity of a conductor is the maximum current it can carry continuously without exceeding its temperature rating. NEC Table 310.16 provides ampacity ratings for various types of conductors based on their insulation type and ambient temperature. It's important to select a wire gauge that is appropriate for the circuit's ampacity requirements. Using an undersized wire can lead to overheating, insulation damage, and potentially fire hazards. Pay close attention to the voltage rating of the THHN wire. The voltage rating indicates the maximum voltage the wire can safely handle. Ensure that the voltage rating of the wire is equal to or greater than the voltage of the circuit. Using wire with an insufficient voltage rating can result in insulation breakdown and electrical hazards. When installing THHN wire and conduit, use appropriate pulling lubricants to reduce friction. This simplifies the pulling process and minimizes the risk of damaging the insulation. Avoid overfilling the conduit, as this can make it difficult to pull the wires and may damage the conductors. Follow the conduit fill requirement specified in NEC Chapter 9. When terminating THHN wire, use properly sized connectors and terminals. Ensure that the connections are tight and secure to prevent loose connections, which can cause overheating and electrical arcing. Use a torque wrench to tighten the connectors to the manufacturer's specified torque. Always de-energize the circuit before working on any electrical wiring. This prevents the risk of electric shock and ensures your safety. Use a voltage tester to verify that the circuit is de-energized before beginning work. When splicing THHN wire, use approved splicing methods and materials. Ensure that the splices are properly insulated and protected from moisture. Use wire connectors that are specifically designed for splicing THHN wire. Never use tape alone to insulate splices, as this is not a reliable method of insulation. When running THHN wire through metal studs or other sharp objects, use grommets or bushings to protect the wire from abrasion. This prevents damage to the insulation and reduces the risk of short circuits. Inspect the THHN wire regularly for any signs of damage, such as cracks, cuts, or abrasions. Replace any damaged wire immediately to prevent electrical hazards. When working with THHN wire, wear appropriate personal protective equipment (PPE), such as safety glasses and gloves. This protects you from electrical shock and other hazards. Always follow the manufacturer's instructions when installing and working with THHN wire. This ensures that the wire is installed correctly and safely. Consider the environmental conditions when selecting THHN wire. In wet or damp locations, use THHN wire that is specifically rated for wet locations. This wire has a moisture-resistant insulation that prevents water from entering the conductor. Select a conduit material that is compatible with the environmental conditions. For example, PVC conduit is suitable for many wet locations, while rigid metal conduit provides superior protection in harsh environment. When installing THHN wire in direct sunlight, use wire that is rated for sunlight resistance. Sunlight can degrade the insulation of some types of THHN wire over time, leading to premature failure. Choose a THHN wire with a sunlight-resistant insulation to ensure long-term reliability. When installing THHN wire in cold temperatures, use wire that is rated for cold weather applications. Some types of THHN wire can become brittle and crack in cold temperatures, leading to insulation damage. Select a THHN wire with a cold weather rating to ensure it remains flexible and durable in cold environments. When installing THHN wire in high-temperature environments, use wire that is rated for high-temperature applications. High temperatures can degrade the insulation of some types of THHN wire, leading to premature failure. Choose a THHN wire with a high-temperature rating to ensure it can withstand the elevated temperatures. Consult with a qualified electrician if you have any questions or concerns about using THHN wire. A qualified electrician can assess your specific needs and recommend the appropriate wiring and conduit system for your project. They can also ensure that the wiring is installed correctly and safely, complying with all applicable electrical codes. Remember that working with electricity can be dangerous. Always take the necessary precautions to protect yourself from electrical shock and other hazards. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. When comparing THHN wire to UF wire, consider the specific application and the environmental conditions. UF wire is designed for direct burial applications and is resistant to moisture and abrasion. THHN wire is more versatile and can be used in a wider range of applications, but it typically requires installation within a conduit or raceway. The decision of whether to use THHN wire or UF wire depends on the specific needs of your project. If you need a wire that is resistant to moisture and abrasion and can be directly buried, UF wire is a good choice. If you need a more versatile wire that can be used in a variety of applications, THHN wire is a good option, provided it's installed with suitable protection. The flexibility, cost savings, and availability of various sizes and colors make THHN wire a practical choice for many electrical projects. However, always remember to prioritize safety and comply with all applicable electrical codes. Understanding the properties of THHN and UF wires is key to making informed decisions for electrical installations. Both wire types serve distinct purposes, and selecting the right one ensures safety, efficiency, and compliance with regulations. THHN, which stands for thermoplastic high heat resistant nylon coated, is a common type of built-in wire. Its construction features a thermoplastic insulation layer, providing resistance to heat, moisture, and chemicals. A nylon jacket further protects the insulation from abrasion and mechanical damage. THHN wire is primarily used in conduit or raceway systems for various applications, including residential, commercial, and industrial wiring. Its versatility and relatively low cost make it a popular choice among electricians and contractors. UF wire, short for underground feeder wire, is specifically designed for direct burial applications. It features a solid thermoplastic insulation that provides excellent resistance to moisture, chemicals, and abrasion. UF wire is commonly used for underground wiring, such as supplying power to outdoor lighting, pumps, and other equipment. Its robust construction allows it to withstand the harsh conditions of direct burial without requiring additional protection. When comparing THHN and UF wires, several key differences emerge. Firstly, THHN wire requires insulation in a conduit or raceway, while UF wire can be directly buried. This difference stems from their respective insulation properties and intended applications. Secondly, THHN wire is generally more flexible than UF wire, making it easier to work with in tight spaces or complex installations. UF wire, on the other hand, tends to be stiffer due to its solid insulation and direct burial construction. Thirdly, THHN wire is typically less expensive than UF wire, making it a more cost-effective option for certain applications. However, the overall cost may vary depending on the specific project requirement and installation costs. Considering these differences, the choice between THHN and UF wires depends on the specific application and environmental conditions. For indoor wiring or installations requiring conduit, THHN wire is often the preferred choice. Its flexibility, affordability, and wide availability make it a practical option for various electrical projects. For underground wiring or direct burial applications, UF wire is the clear choice. Its robust construction and moisture resistance ensure long-lasting performance in harsh environments. In some cases, a combination of THHN and UF wires may be used in a single installation. For example, THHN wire may be used inside a building, while UF wire is used for the underground portion of the wiring. This approach allows for optimal performance and cost-effectiveness. Regardless of the wire type chosen, it's crucial to follow all applicable electrical codes and safety regulations. Proper installation techniques, including the use of appropriate connectors, grounding methods, and overcurrent protection devices, are essential for ensuring a safe and reliable electrical system. Consulting with a qualified electrician is always recommended to ensure that the wiring is installed correctly and safely.